All right. Good morning from my end. Good morning. Yeah. So today is the third day for week two. So the last day for week two. From tomorrow or next, I should be dropping the video for the week three. So we round up for the month. All right. So today on our schedule, we have error handling and debugging. Right. Error handling and debugging. So far. We've been able to write some codes and we've sometimes encounter errors, right? And sometimes we see that our our program run into one error or another. So we want to learn how to spot those errors before time and see how we can handle them to ensure that our codes run effectively. And also debugging is debugging, whenever we experience such errors or whenever we experience errors, how to maneuver such errors and see how to correct where we went wrong and ensure that we have a very good code running for us, a program that is running. So by way of definition, error handling and debugging are essential for creating robust and efficient programs, right? So if you're writing a very, very robust program, when I mean by robust, it encompasses so much um characters and it has to do with so much features, right? So by so doing, you will need to include some form of you need to have a knowledge of error handling and as well know how to debug your code because once your program becomes so robust, there is that tendency of you not being able to spot where your error is coming from. So you need to be very, very attentive. And also efficient programs. What efficient program means is that when you've handled your errors correctly and your debugging skills are very active, you realize that you'll be able to your programs are going to be optimized, and once they're optimized that way, the efficiency will also be um, um, at the zenith, like it will to have increased. So learning how to handle exceptions and debug effectively allows you to anticipate and manage potential issues in your code. Okay, so when we talk about error handling, one of the best way to account for errors is the use of what exceptions, right? So these exceptions allows you to accommodate some form of errors into your code by way of defining those errors and giving them a little or more allowances where they can freely run with respect to the exceptional codes you've included into your programs. So, and debug effectively. So even while you give that tolerance in your code or in your program, you realize that there are still some areas where you need to debug, right? So where you need to, in case you run into an error, how to come back to fix them and all that. So All of these are needed at time before even running your code, because you have to anticipate and manage potential issues are you're foreseeing those issues, right? So you know they are going to come up. So what do you put in place to ensure those errors are being taken care of? So all of this is to ensure smooth execution and maintenance. So I broke this study into two topics. The first is what exceptions. Remember, I talked of exceptions. And then under exception, there are just three things we need to do. We need a try and accept and final. We need a try, accept, and final block of code, right? So these are just the three. These are just the three things we need to know and understand when it comes to exceptions. And then I'll try to release some debugging tips and tools that will help you to um debug your code effectively. And then there'll be a practice where I'll give you a code. The code has so many errors, and I'll expect you to correct them. All these are going to be self-taught, right? So that I'll see your expertise in this kind of scenario, right? So the first topic, exceptions in Python. Exceptions are errors that occur during, sorry about that. Exceptions are errors that occur during program execution. So they are errors that occurs during program execution. Disrupting the flow of the program instead of what? Letting your program crash. Okay? So when you try to disrupt the flow of your program instead of allowing it to crash, what I mean by that is that you have a block of code, and then you don't want that code to crash, right? Or that program to crash. So there are some exceptions you include to allow the code or the program run effectively. So Python allows you to handle these exceptions gracefully the try, using the try, except, and final block codes. So these are the blocks you use, the try, except, and final block codes. So let's look at this component critically. The first one is what? The try block. So in the try block, the code that might cause error is placed here, right? So there are code that could cause error. You place them in this try block. So let's say, for instance, you have a division, okay, you have a division kind of code or program, or you wrote a program to help in the division of numbers, right? And then you know that when any number is divided by zero, it gives us and it gives, actually, in the real sense, I think it gives infinity or thereabout, or rather undefined, right? So that's the error you get, the error of undefined. So In this case, you can always include that particular uh causative, that when a number is divided by 0, try to handle that so that it doesn't throw out an error. So if no error occurs, the code in the except block is skipped, right? The code in the except block is skipped. So if there is no error here, the one on the except block is not gonna run. So the try gives birth to the except. So except block, once you include the code here, the except block will now handle the specific exceptions you're trying to incur into your code, right? So if an error occurs in the try block, control is passed to the appropriate except block. So this is it. The flow starts from try block, and once there's an error experienced in this try block, there will be a control that will be released in the except block, right? So final block contains the code that is always executed. So final block is where you have your normal the the code that should be executed at all times. Either when there's an error or when there's no error, the code has to be executing at all times, regardless of whether an exception occurs or not, right? So typically, um, used for cleanup actions like closing files or database connections. So we use it at the end of that particular code. So I have a simple line of code here. So this is the block for the try, right? Remember I told you whenever you see an indentation like this, you should know that this is a block of code. So when it comes back to the edge like this, that starts another block of code. So I have here the try, a number. So we demand the user to enter a number, right? And that number is going to be the divisor, what we are dividing by, right? So the result is 10 divided by that number. So we need a number. We need a number that we want to divide 10 by, right? The essence is to see how to handle errors when you're dividing 10 by a number, most especially when the number is 0. So print the result is thus, right? So here we have the block of code that we are trying to execute. And if there's any error that comes up from here, so we say except division, 0 division error. Okay, so let me show us what the 0 division error implies. Let's take this, come up, right? So we'll see here that if we have, oh my keyboard, if we have if we run this guy now, and then I input 0 here to run it, what's happened? Okay, sorry, let me kill this kernel and let's start afresh. Uh, okay, so I have the number to be 0. I need this number to be 0, please. 0, right? Yeah. So let's run this. You see here, the error, the error that is raised is known as zero division error, right? Is zero division error. So division by 0 usually raised an error. So another thing you should take note of is when you're trying to accept an error, you need to know the kind of error you're accepting. So because we know that when you divide a number by 0, it will give you what? A 0 division error. That's why we came here and say except, like exclude 0 division error. All right, there are cases also whereby at this point we could have an alphabet. At this point, we could have an alphabet. At this point, we could have an alphabet. At this point, we could have an alphabet, right? So if I should run this guy now, I'll be having what? A name error. So you can also include this, right? You can also include this as part of your exception. So if you, mind you, if you look very closely at this, you see why I included except 0 division error. So print, you cannot divide by 0. That's the first exception. Then except value error. Please enter words a valid integer. Please enter what? A valid integer. So that will, let's try for that. Let's see. 6, I think 6 should be a valid one. So 6 will run, right? Let's try 1.6. Sorry, 1.6 is what I want to try. So I want to see. Okay, it's still run. So here, let's come back here. If we do this, and then we are using 6. We are using what? 6. And we run this. There is something wrong somewhere. So we have to interrupt this again. My PC is just faulty. Okay, let's go over it again, please. So we are using 6 to be our number, or rather 1.6. We can start with 6. 1. Let's see 1. So 1, the result is what? 10 point 10.0. 10 point what? 0. Then execution completed, right? So when I run this with, let's say, 0, and I run it with 0, you see there will be an error that is raised saying what? You cannot divide by 0, and execution is completed. So in real sense, your code ran, right? So let's see the difference between this guy and this 0. Sorry, this should be 0, right? Let's see the difference. The difference here is that, are you seeing this? Is a 0 division error, trace back most recent call cell line 2, right? At the same number, 0 is what we are using here. But this guy ran. Reason is that there was an exception included, right? So what came out from the exception is print error, you cannot divide by 0. So that will prompt the user to go back and probably change this number to either 6, 5, or 6, or 56, as the case may be, right? So that will show you what to do. And then the final block, mind you, you can always have multiple exceptions or excepts block depending on what you're working on, right? But but you can only have one try and one final. The final comes either the code runs perfectly well, or it's prompted, or it's made use of except, so it will still turn out well. So explanation, let's explain what all of this is. This is just maybe when I send the notebook, you can always go through it. So the try block prompts the user for input and performs division, right? So the try block prompts the user for input and performs division, while the except 0 division error, it caches the error and then tries to divide it by 0, while this one, the value error, caches the error if you what input if the input is not a valid number, right? There's another one, name error. Name error. When you're using an alphabet instead of a number, right? Then the final execute regardless of the outcome indicated to indicate that the program has completed, right? So those are the specifics of this block inline of this block cell 13 we just ran, right? So let's try to catch up multiples exceptions. Here we are we are we are trying to check for a file. Let's check for a file. So the first is open a file or open non-existent file.txt, right? This is when you're trying to open a file. And this kind of file is a text file, either a Microsoft Word or a Notepad kind of file. So this is how you open your file. We do open, right? And then the file name, mind you, this file you're opening should be in the same directory where this notebook is. And then now R indicates read. That means we want to open it in a readable form. We are not editing that file, but there are some where we can read and write. So read and write, you know you're editing the file, right? So data is equal to file.read. So while R represents read, W represents write. So if in case you should have a W here, what should come into this guy should be a write, right? Then number is equal to input data. Input data. So we can use a number. Let's say for instance 56. So we have a number already, 56, except file not found. If the file is not in that directory, you're saying what? Print the error. The file does not exist. Value error. The file does not contain valid integer. Then your exception, your final rather will be attempt to process the file completed. Right? Let's run this. You see that the file does not do what? Exist, because if we come to this directory where we have this guy, realize that we don't have the file here, right? So that is that. So explanation handles both file not found error and value error. So let's say for instance we had uh GH here. What should have been? Okay. There's another thing I didn't explain. Once the first error is experienced in the except, that is what is gonna pop up, right? So because Python works with the hierarchy of your code, or rather, will I say, because Python executes from the top to bottom, so when it gets here and realizes that the file is not found, it will automatically print out this guy, ignoring what the value will be, right? So that is that. So ensures a final message is displayed if the file does not exist or contains invalid what? Data. So that's that. We can also using else we try. Using else we try. So I want to see how we can make use of else. You know, when we talk about else is when we are dealing with if, else, and if, else statements, right? So, but now we want to see how to incorporate else into the try, except, and final blocks of code. So let's go. So we have here, we need to enter two numbers. I'm giving us the numbers, so you can always edit to show your own number. 6 and 5. We have 6 and 5, right? And then except 0 error division is allowed. Is not allowed. Or division by 0 is not allowed. That's when we are including this. That means your second number cannot be 0. So for any reason you're having your second number to be 0, it will be captured here. And also, values error. Please enter a valid number, right? So the else function is where prints the result is this. So if all of this is not experienced, mind you, here is where we wrote the code and we wrote what we need. That want to divide the first number by the second number, right? But we are now checking, are there some forms of errors we could experience during this division? If yes, handle those errors here first, right? Then if no, let's bring out the results we are going to get. And then your final is always for to show that your code has been executed successfully. So let's try to run this. The result is what? 1.2. The program executes shown complete. Reason being that Our first number is what? 6, and our second number is 5. So 6 divided by 5 give us 1.2. So what if we have I'm looking at us, can we have a 0 here? Let's see. Let's get 0. Yep, this should serve. Okay. Right, so here is it. The error pops up under this. So division by 0 is not allowed, right? Okay, so the else block ensures that the success message only appears when there is no exceptions occurring in the block of code. Debugging tips and tools. Debugging tips and tools. So debugging is a process of identifying and fixing errors in your code. So Python provides several tools and techniques to streamline this process. So the first one is use print statement. Insert, this should be insert, please. Insert print statement to inspect variable values or program flow. So the print statement you insert is to ensure that what you're doing is correct, right? So here is it now. Calculate total. Remember what we did about function last class? So you have the price, you have the quantity, and you want to know the total. So you multiply the price by what's the quantity, right? So, but before you do that, you print out what the price is and what the quantity is. So that in case you experience an error here during this execution, you will know, so, okay, the values I entered were not correct. So imagine somebody having 0 to be a total price. It means that either the quantity or the price was what? 0. So if we should run this now and you're seeing your total to be 0, you already know that, oh, I included my quantity to be this should be quantity, not quality. Quantity. Sorry, this guy should be quantity, not quality, please. Pardon me, that was typo. All right. So let's run this again. Price, quantity, right? 0. Then that's why you're having your total to be 0. So, but then we could have this guy to be 6. So let's see. Our total will be what? 20. So your print function can help you try to debug information you input into the program. Also, leveraging the Python debugger. The Python debugger modules allows you to to step through code interactively. So you have to import it and then set it up. Setting it up has to do with Python debugger dot set underscore trace open and close bracket. And then we have two numbers here. I'm working with 5 and 6 today. So we have here 5, sorry. We have 5, we have 6 here as well. Come on. And then you have a print statement that tells you the sum of this guy and this guy is what? 6. So, but let's see how this would trace the number. We're having 5, right? So I have to bring up my keyboard now because my PC's keyboard is... All right. So it will just be checking for the numbers, right? To be repeating the 6 you imputed and all of that. But this is not usually advisable because you can take the whole day before it's execute, right? So I don't advise this. I just brought it up because it's just one of the ways to ensure your program runs. So also, I have some programs I wrote here that I need you to debug. So you tell me how to debug them. Although I've written another program behind to account for it. So you go through it and ensure that your program is free of all of those dirty errors, right? So today, that will be all for today. We'll meet tomorrow or next so that we can have the final, so that we can resume the week 3 classes and see how to wrap off for the month. All right. Thank you very much.